Welcome to this explainer. Today, we're unpacking domain-driven design, or DDD, and we're going to solve the ultimate tech mystery. Why do perfectly good developers sometimes end up with legacy systems that look more like a giant bowl of spaghetti than a sleek business engine? We've all been there, right? Staring at an architecture diagram that just doesn't make any sense. Well, let's dive right in and untangle this mess together. Okay, kicking things off with our first section, the tangled software problem. You know the systems I'm talking about. They look like a completely tangled web. Just picture it. You've got disconnected databases, APIs firing off everywhere, customer requests somehow getting lost in the void, and business roles held together with, I don't know, digital duct tape. It really begs a massive question. Why on earth does software become such a tangled mess in the first place? I mean, it's super easy to just point fingers at developers or blame the code, but honestly, that's rarely the whole story. The true culprits are actually rarely technical. The real issues usually stem from incredibly complicated, real-world business problems. You know, rules change overnight. Requirements get lost in translation, literally from day one. And the absolute biggest offender? Crosswires. It happens when engineering and business teams use completely different words for the exact same idea. Over time, because of these communication breakdowns, the software just starts to feel totally disconnected from the actual business it was originally built to support. So, how do we fix it? Let's move to Section 2. Meet domain-driven design. This methodology really exploded onto the scene back in 2003. That's when Eric Evans published what the industry affectionately calls the Blue Book, mainly because of its super recognizable cover. But as you might guess, the real magic of this concept isn't just in a catchy title or the color of the binding. The secret sauce is actually hidden right there in the book's subtitle, Tackling Complexity in the Heart of Software. This approach is absolutely not about making the surface look pretty. No way. It's about managing that stubborn, deeply rooted complexity that lives right inside your business logic. To really demystify this, let's just break the name down. First up, design. Now, in this context, design means the internal architectural structure. We're talking about how your code is organized, how your business rules are constrained, and how easily the whole system can pivot when the business inevitably changes. So we are talking pure architecture and logical structure here, not colorful buttons or user interfaces. Then we have the domain. This is just the specific area of business you're actually operating in, whether that's routing logic for a grocery delivery app or, say, fraud detection in a massive bank. The core principle here is that your software architecture must be shaped primarily by this business domain. Sure, cloud services and shiny new databases are awesome, but they're strictly secondary. The business problem has to be your absolute starting point. Which brings us right to Section 3, Bridging Two Separate Worlds. Imagine software development as two completely separate islands. On one side, we have the problem domain. This is the business side of things. It's filled with customer workflows, market constraints, and revenue goals. On the other side is the solution domain. That's the developer's territory, packed with code, databases, and APIs. So, the extremely crucial point here is that domain-driven design acts as a highly intentional, meaningful bridge connecting these two distinct worlds. The real job of software development isn't just mindlessly writing code. It's building this bridge so the technical solution directly reflects the actual business problem. DDD gives teams the specific, concrete principles to construct that connection. Let's look at the secret weapon that makes this bridge so strong. In Section 4, the power of shared language. You know the old joke, right? Naming things is one of the hardest problems in computer science. Well, that's exactly what we're tackling here. You can't just slide a giant list of requirements under the door and expect developers to translate it into perfect code in total isolation. It just doesn't work. Both sides have to collaborate continuously using a shared, ubiquitous language. Yeah, it sounds a bit formal, but it is literally the absolute bedrock of domain-driven design. What this actually means in practice is that the exact same vocabulary you use in a casual whiteboard session with a business expert must appear in your architecture diagrams, it must appear in your automated tests, it must even appear in your variables and classes in the codebase. When the language is unified from top to bottom, the model becomes crystal clear, which prevents incredibly expensive misunderstandings down the line. To move from theory to reality, let's jump to Section 5, Groceries, a real-world example. Let's trace a standard online grocery delivery business through 3 logical steps. Step 1, shopping. This is where the customer's browsing the app and tossing items into a virtual cart. Step 2, the warehouse operations. This handles stock availability, picking the items off the shelves, and packing them up. And step 3, delivery, which is all about optimizing those driver routes. These are pure, fundamental business domain activities. Now, your software solution for all this might involve some massive, complex cloud infrastructure. But domain-driven design dictates that your technical pieces must be designed directly around the business concepts they support. So your back-end services should be organized cleanly into shopping, inventory, warehouse, and delivery modules. They're driven entirely by the business needs, not by whatever shiny new tech framework happens to be trending today. Let's bring it all together in our final section, embracing organized complexity. So, what does this all mean? What are the ultimate goals here? Well, by making the business domain the absolute center of your design process, by creating models that accurately reflect real business rules, and by strictly enforcing that shared ubiquitous language, your system stays perfectly aligned with user and business needs. It stops being a random, chaotic collection of databases and becomes a highly organized, true reflection of the business itself. But, hey, here is a crucial reality check. Domain-driven design does not magically erase complexity. Enterprise business is just inherently complex. There's no getting around it. Instead, DDD gives you the tools to understand it, organize it, and express it clearly in your code. It ensures you don't end up with that disconnected, tangled spaghetti we talked about at the very beginning. It's a real game changer for systems where getting the model right is honestly just as important as writing the code itself. As we wrap up this explainer, I'll leave you with a final provocative thought to chew on regarding your own systems. Is your software actually speaking the language of your business, or is it lost in translation? Thanks for joining us today, and here's to building better, more meaningful software bridges.